Alright guys, so we are on our last two set of problems. Now this one is example 5, and it's a little different from the rest of the problems that we've been solving. So this one says to prove or disprove the point square root of 2 lies on the circle centered at the origin and containing the point 2, 0. So in this case, the origin is here is just 0, 0. And so if you remember before, so we have this point here and it lies at the origin. Well, the origin here is 0, 0 and containing the point 2, 0. So we're not exactly sure. We don't know the radius yet, but we know that this is my y. I'm just going to do a quick sketch. So this is the center. The point here that they're claiming is on the circle. It would be at square root of 2. So let's just sketch something around here. Okay. And I know that because it's on the positive side. So positive, that's going to be on this quadrant here. And it's only the square root of 2. So that's a very small number. It'd be like about 1 point something. And then containing the point 2, 0. So 2, 0, let's just say it's about here. So we're making this prediction that this circle is about this big, right? Now, in order for us to figure out exactly how to draw or sketch our graph, we would need to know the center and the radius. So before we do that, we need to find the radius. And we're trying to find if we're trying to prove or disprove if this point is even on the circle, but we know for sure that this point here is definitely on the circle. So I'm going to go ahead and find the distance here, and that's going to be my radius. So let's go ahead and do that. I'm going to go ahead and find the distance. Now again, when we're trying to find the distance, we're going to be using the distance formula. So here, distance formula is the square root of y2 minus y1 squared plus x2 minus x1 squared. Now I'm just going to go ahead and plug those values in. So I have the origin 0, 0 and 2, 0. So I'm just going to go ahead and say that this is x2, x2, y2, and this is going to be x1, y1. So let's go ahead and plug those values in here. So y2 minus y1, that's 0 minus 0 squared plus x2 minus x1, x2 minus x1, that's 2 minus 0 squared. And when I simplify that, now this is just going to go away, 0. And this is 2 squared, which is 4. And the square root of 4, I know, is 2. So now I know that my radius here is 2. So here my radius is 2. And I'm just going to go ahead and make a note. Radius is 2. Okay, so I'm going to go ahead and just erase this for now. Okay. And now that I know the distance is 2, that means that if this point is on here as it's claiming to be, right, then then the distance from here to the origin also has to be 2. So I'm going to go ahead and find the distance between these 2 points and determine if the radius is indeed 2. Or sorry, if the distance is 2. So let's go ahead and redo the distance formula. So here again, I'm just going to quickly y2 minus y1 squared plus x2 minus x1 squared. In this case, since it's already, my origin is x1 and my y here is my origin is already as x1 y1, I'll just go ahead and do x2 y2 and plug those values in. So y2 minus y1, that would be just square root of 2 squared plus, I already did this in my head because it's square root of 2 minus 0, it's just square root of 2. And then in this case, it's the same thing. Square root of 2 minus 0 is just square root of 2 squared. Now, these cancel, right? They're opposite, they're inverse functions. Or I could have done it as the square root of 2 times square root of 2 is square root of 4. Square root of 4 is 2. So this is 2 plus 2, which is the square root of 4. Square root of 4 is 2. Yay! So that means that the distance is 2. Therefore, this coordinate is correct. Alright, so this is example 5, and then we're going to go ahead and move on to the next example.